Microsoft NoSQL or document style databases that use key value pairs. There's object storage or blob storage where we store content, okay? Not stuff that we would access like through a database, not transactional, not a lot of read writes, but things that we're storing, maybe the back end to your web services, you know, your graphics, your pictures, your PNG files, the stuff you're streaming, the audio, the video, things you're archiving like PDF files, object storage, and then a wide variety of applications and various services. And as each week goes by, we see more and more of those, okay? So this is what we would call kind of the cloud computing value proposition. And really at the top of the list would be just lower cost. But that one kind of goes without saying, right? Obviously, by not having our own facility that we're either having to pay a lease on or we are borrowing tons of money to have our own racks and racks of servers and our infrastructure, by not having to have that, that's obviously cost savings. But there's other things that are really what are special about cloud computing and its value proposition. Just the ability to create an account very easily. Now you have to have some type of credit card or debit card or bank card, or organizations, larger ones, can do direct billing. But once you create that account, and I'm going to give you a video. It's a video that I made for my Amazon Web Services Cloud Practitioner, which would be a good certification for you to get. Okay, probably the next step would be get some kind of certification that says, hey, I know about cloud. But for that course, I made a little 6-minute video of me setting up an account. So I'll give you the link to that YouTube video later. So, you know, once you get that account set up, you just have this on-demand self-service, this portal that you can just go and bring up whatever you want to. Lots of people and customers and businesses will work at a cloud provider and never even interface with a human being. Everything is just done through this self-service portal. Now, do you have the ability to talk to architects and engineers and 24/7 tech support? Absolutely, but not necessarily, okay? We're going to talk about broad network access, and that means several things. One, it means these cloud providers, Google, Azure, IBM, they have regions all over the world, okay? Not everywhere. There's a few places you're not going to see a cloud provider's region, like, you know, North Korea or something like that. But, you know, in all the continents, they'll have a region, okay? And we'll talk about what that consists of here in a moment. So they have regions all over the world, and they have what are called edge locations in metropolitan areas all over the world. And that's where that CDN thing comes in, which we're going to talk more about. This is content delivery networking, okay? I just watched a Netflix show last night. It was a new one, and it was in German. I don't mind. I like to watch things, you know, from, you know, other countries. It was in German, had subtitles, and when I streamed that on Netflix, my system was not hopping across the internet and going to like Hamburg, Germany, and getting that video and streaming it from Germany. No, Netflix was using Amazon Web Services to get a copy of that cached very close to me. As a matter of fact, in the Dallas-Fort Worth area. So when I was streaming this Netflix, you know, show, this 1-hour show, I was streaming it using content delivery networking, okay? Getting it from the Fort Worth area to be exact. So broad network access also means all different types of devices now. It's not just, you know, accessing cloud resources with a static standalone workstation, right? All different types of devices. And IoT, the Internet of Things, right? Everything eventually with an IP version 6 address, probably identified with a QR code, who knows? And then, of course, the multi-tenancy resource pooling. And we'll talk about the hypervisor technology that supports that. That's where we can get our costs down. But also, let's say you're hosting some web services up in the cloud. Let's say you actually want to go up and put some Apache or Nginx web servers, and these are virtual. You want to put them into a network that is public so that people can go through a gateway, a logical gateway, and they can access these Apache servers. Well, back around the turn of the century, during the dot-com boom, if you, let's say, had a bunch of web servers, you probably were hosting them at your site, or maybe your service provider was hosting them. And if you decided to go out and do an advertising campaign, at the Super Bowl, or, during some, soccer or football event, an advertising campaign for your new .com, what would happen was everybody would watch the commercial, go log in to their PC, get on their browser, and go up to your website and get the web page off your web servers. But if you didn't have the infrastructure for it, if you didn't have the servers and the database, and it was physical back then, they would just get hammered. And all that money you spent on advertising went for nothing because you weren't able to handle the demand. Okay? Today, when you deploy these servers into a subnet like that, you can have auto scaling. So they will automatically, on demand, scale up, and you can define that. And you can say, this is the most I want to scale up to, 100. No more than that, or I start losing money. But you can rapidly provision, okay? Elastic. But the other thing about elasticity or rapid provisioning or auto scaling is the other side of that coin, okay? Think about you're a company that before the pandemic, you were running a lot of your services in the cloud, maybe doing your DevOps in the cloud. You had migrated your database to the cloud. And then here comes the pandemic. Now, because of deprovisioning or the other side of elasticity, you can just stop using those resources in the cloud because you pay as you go. You pay as you grow. So if you don't need the resources because you have to operate at 75% now or even less, you can ride out the storm. If you're not that type of organization where everything's on premise and you're leasing this facility and you borrowed all this money to buy this infrastructure, it just sits there and goes dark. But you're still making your payments. You're still paying the lease. You're still making the payments to Cisco or whoever. Okay? So rapid elasticity, we found out that, the ability to scale up and to provision, that's really important. But the other side of that, deprovisioning, can be just as important. It can allow your company to continue to operate, okay, for a while. All cloud providers are going to offer lots of different tools, visibility tools, monitoring tools, ways to keep track of all the API activity, all the application programming interface activity that's done in the cloud, your billing, and be alerted and get alarms. Okay, so a lot of tools to make sure that you get the most bang for your buck. Okay, a cloud provider, it's kind of like when you have a kid who's going off to college. I have a granddaughter who's a senior in high school, so she's going to be going off to college. And it's the way universities work. They try to get the kid to be the first one and get them to come visit the campus. Because they know, usually, a lot of kids, not all of them, but a lot of young people, that first impression, if that college or university can make a really good first impression, the student will tend to go with that. It's the same thing with a cloud provider. Once you get up there and start using Google Cloud, they don't want you to go and use somebody else necessarily, unless you're a really large organization and you're purposefully in a multi-cloud environment. You know, they want you to get the best bang for your buck, okay? And regarding that, cloud providers will send you at the end of the month one consolidated bill. For example, AWS has what's called an organization. And in the organization, you can have organizational units. And the organizational units are just groups of accounts that you have based on departments, projects, business units, programs, and you can take that consolidated bill, which is broken up into organizational units, and you can charge back or show back to those departments based on their budgets. Because the chances are departments don't have the same budget, right? The R&D department, the developers probably have a bigger budget possibly than the marketing department, okay? So you get the idea. So these are all kind of value propositions. What drives this technologically wise is fast and highly available wide area and metropolitan area networks. When we look at cloud providers today, all of them are offering really high speed direct connect capabilities, not just 10 gig, but like Amazon Web Services. If I'm in Houston or I'm in Chicago, I can get a 100 gigabit per second direct connection to the AWS cloud through a partner in Houston or Chicago. Okay, so I can basically take my headquarters or my regional branch office and make it part of the cloud's internet with 100 gigabit connectivity, and they have 100 gig in their data centers. Extremely fast. Okay, not fast Ethernet. We're talking 100 gigabit. Advanced tools to help automate and orchestrate. Advanced tools to leverage things like machine learning and artificial intelligence. Those are key enabling technologies. They have very powerful servers that are inexpensive from the sense of not if we had to buy them. If I want to do high performance computing with really high-end processors and really fast cards, it's going to be very expensive to deploy these on site. But I have the ability to lower my cost and go do it cheaper by doing it in the cloud because I'm sharing that with other customers. Okay, and then virtualization. Well, let me give you a kind of a picture of what we call the global infrastructure. So I've got like when you download your slides. Oh, by the way, we're going to take a break about every hour. Okay, so we'll take a 10-minute break around the top of the hour. And my goal is to go 4 hours. We won't go past that. We may not go all the way 4 hours, but once I feel like I've worn you out, you may just stop there. Okay, so like here's a picture of the AWS global infrastructure. This is a little bit older of a diagram. Here's the Microsoft. Okay, and those blue circles are regions. So you can see that these are regions and they're on all the continents, right? And yes, we don't have a lot of regions for Microsoft in South America or Africa, but in South America or Africa, we do have what are called edge locations in certain cities, okay? So this is kind of the global infrastructure. So let me kind of explain what this infrastructure is, and we'll use this example right here, okay? So this is pointing to the North Virginia region of Amazon Web Services. By far the largest. I wouldn't say by far. I think we have one in Japan that's like pretty big too. But the number 6 means that there are 6 availability zones in that region. Okay. So we can kind of visualize what a region is. It's a pretty large geographic area. This is, Northern Virginia. So we're talking about the nation's capital, Northern Virginia. We've got other cities like Baltimore, Washington, like North Carolina is actually kind of a big IT hub with lots of universities. So you get the picture, right? Here's what an availability zone is not. About 20 plus years ago, on 9/11, 3 towers collapsed, not just 2, there were 3 buildings that went down that day. A lot of those companies were financial services companies, brokerage firms, law firms, things like that. And they had their high availability, like their backups, their redundancy, their failover solution, their high availability in one of the other buildings, and vice versa. Well, these buildings were like yards or meters apart. Yards or meters apart. That's not what availability zones are today. A cloud provider's availability zone is going to have at least 2 data centers. Now, the data centers may be relatively close to each other, like on a metropolitan area network or what we call a FDDI ring, at least 2 data centers. But the availability zones are miles apart, not just tens of miles apart, but miles apart in that region. So AWS has 6 availability zones in that Virginia region, so that if one of the availability zones suffers some event, they're far enough apart, okay, miles and miles apart, because the technology that they use theoretically can be stretched up to 800 kilometers, that's 600 miles, right? So these availability zones are miles apart, okay? So that's what, when you see a region and a number in it, that's what we're talking about, okay? And that's, how a company, even a medium-sized company or a startup or some other company, can really get high availability. They don't have to go and say, we have to create this company, or we have to take our company and have not just a headquarters, but we have to have like 5 or 6 other locations where we distribute everything, and hopefully it's far enough apart so that some event doesn't take us out. We just leverage the cloud, okay? I'm going to do a little screen share here. And sometimes it has to, like we say in the United States, rob Peter to pay Paul. Like, you have one operating system or application that's not really that busy right now. Well, I allocated these resources to it. When I run it, it has those resources allocated to it, but it's not using them. So I'm going to borrow them and let this other operating system with its hungry application use this until this one needs it again. So it's a very important piece of software in a cloud environment at the data center of Google or Azure or IBM. These are huge clusters of these hypervisors. Okay, just imagine huge racks of them. Okay, so there's some that are proprietary, like from VMware, for example, and there are some that are open source, right? So Google and AWS, they use the Linux KVM for the most part. They also have some of these have their own proprietary special use case hypervisors. They're getting to the point now where cloud providers are actually creating their own, right? So for example, Azure, they have kind of their own version of Hyper-V. It's not the same Hyper-V that we would install necessarily in our organization, okay? And IBM has their own special hypervisor, okay? So you've got, proprietary and then open source. But there's 2 types of hypervisors. The ones that you're using as a customer of the cloud provider is what's called the Type 1, okay? So Type 1 is also referred to as bare metal or native. So I could do that. Like I have a really powerful workstation. I have a very powerful Dell tower. It's got 2 really fast processors with several cores and lots of RAM memory. So if I wanted to, I could go and reformat my solid state drive and install directly onto my workstation one of those hypervisors, right? KVM, OVM, vSphere, whatever. I wanted to, and when I booted up my workstation, I'm booting up into the hypervisor operating system. That's bare metal. That's type 1. That is what they are providing clusters of to their consumers. Now, does that mean they don't use the other type of hypervisor? No, but the other type of hypervisor is more of a testing environment, or something that's you're going to use to do penetration testing or learn how to do vulnerability assessment or test interoperability between applications. Okay, that's a type 2. With a type 2 hypervisor, you still keep your underlying operating system. Let's say, for example, I have Windows 10 Professional, but I've installed 2 different type 2 hypervisors on my Windows system. Okay, I have one that is licensed. Okay, it's VMware Workstation Pro. So I, paid a license for it. I get the updates and all that. I get the support. The other is open source, Oracle VirtualBox, free and open source. So I have those 2 on my system, but if I want to run them, I run them within Windows. Okay, these are not the types of hypervisors that a cloud provider uses to provide services for their customers. That doesn't mean that people that work in a data center or somebody who's a developer won't use type 2 hypervisors on their own workstation. Okay? So that's what's kind of driving this resource pooling, right, in these data centers. Okay? And these clusters of hypervisors are connected to very special types of networks called VXLANs. Okay? Virtual extensible local area networks. Very high-end, very fast, and that VXLAN also supports the ability to stretch the fabric many, many miles between availability zones in a region. Now, we need to understand that there's really 3 main service types, even though there's way more than this, right? There's way more than this. I mean, there's database as a service, there's ransomware as a service, you can go on the dark web and, malware as a service, database as a service, business analytics as a service. So, I mean, the list goes on and on. We're a service-oriented world now, right? We're kind of moving away from, being a highly manufacturing type of, globe, world, to a more service-oriented kind of world. But these are the main 3. So if you were taking like an exam from one of these exam certifiers like CompTIA or ISC squared or something proprietary like AWS or Google or Azure, Microsoft, these are the 3 they're going to want you to know about. Okay, infrastructure as a service, software as a service, and platform as a service. And I am going to visualize this for you. I'm not just going to give you a definition. This is the official NIST definition for you. It's kind of wordy. The capability provided to the consumer, okay, what you're being offered from a provider is the ability to provision, processing, storage, networks, resources arbitrarily. It's your decision. Okay, so what would IaaS, infrastructure as a service, look like, for example, at AWS? It would look kind of like this. So let me put a line right across here, and we don't really care about this opaque data thing. Okay, I just want a line right here. Not a very good line. Let me do another one that's better. Drawing with your mouse is always, fraught with danger. So you already understand or have an understanding that the global infrastructure of a cloud provider, regions all over the world. You saw that. Even South America has a region, Africa has a region. Within the regions, usually there's at least 3 availability zones per region. I also showed you that there are edge locations. These are partners of cloud providers in metropolitan areas all over the world that offer very high-speed connectivity. And this is where that content distribution networking stuff is being cached, right? So you can stream it with relatively low latency, okay? So you have an idea what's going on there, okay? Also, the data centers of the cloud provider, they're very, very secure, okay? They're in nondescript locations. When you're driving through a metropolitan area, you go out into the suburbs. If it's a Google data center or a Microsoft or AWS, they're not going to be like a sign. Okay, the AWS data center doesn't have the smirk logo on it. Now, it may be an Amazon distribution center or some business office, but not the data center. These are nondescript locations, and they go through elaborate business impact analysis to choose the location. Okay, it's not going to be in a probable flood zone. Let's put it that way. And they have their own identity management. Okay, very difficult to get into the data center. You're going to have multi-factor authentication, biometrics, least privilege, all those things in their identity and access management. Okay, and then they have core services. With IaaS, I have the ability to choose what compute services I want to use. I choose what storage services I want. I decide what and how I want my databases to be deployed on their infrastructure in their data centers. It's up to me. I choose the operating system. I choose one of the several ways to deploy the operating system, either going through a wizard or doing it programmatically, or maybe they have what's called infrastructure as code, and I can terraform my environment, my operating system, my network. I decide how I'm going to encrypt the data. Do I encrypt it on my site, in my data center, on my workstation? Or do I use a server-side encryption? It's up to me. I manage the platform and the applications, definitely responsible for the data. I'm the one that makes the decisions about identity and access management. Okay? Am I going to use their IAM service? Like Google and AWS have an IAM service. Azure uses what's called Azure Active Directory or Virtual Active Directory. Am I going to use that, or am I going to say, I've got my own identity provider. I've got my own Active Directory that I'm running on my in-premises, on site, or my directory service or Open LDAP. I'm just going to use that and get federated access to your resources and get a temporary token when I want to do something in a session. That's your decision to make. See, with infrastructure as a service, they're just basically saying, here, we're providing the global infrastructure, the data centers, the foundational services. We're also going to offer you something that you can use to connect to services over our cloud without having to go over the internet. You can make an API call to some service, like, blob storage. We're going to offer that for you. Everything else, your decision. Okay? And I'm going to kind of help visualize that here in a second for you. The next one I want to talk about also has a very clear demarcation point. Software as a service. Okay? Software as a service, basically, pretty much everything is running by the provider. Maybe you're using a supported browser to access that. Maybe it's some custom web client that you're using from the SaaS provider. Maybe it's Chrome with a special add-on or a plugin, something like that. But pretty much everything's running on the cloud. Now, does that mean that you don't have any local files? No. If you're using Office 365, there are some local files. Okay, but from an infrastructure standpoint, right, it's all running in the cloud. And it's very common for SaaS providers like Workday, Dropbox, people like that, they're most likely using the infrastructure as a service of one of the big ones, IBM, Oracle, Google. Okay? So you're using this SaaS provider to do your enterprise resource planning, or this SaaS provider, you're saying, I'm going to do my payroll through them. They're probably using one of